Hello guys, welcome back to my YouTube channel. So today we are going to solve day 3 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem 1590. Make sum divisible by p. Let's read the problem statement first. We have given an array of positive integers nums. Remove the smallest sub-array, possibly empty, such that the sum of the remaining elements is divisible by p. It is not allowed to remove the whole array. We have to return the length of the smallest sub-array that you need to remove, or -1 if it is impossible. A sub-array is defined as a contiguous block of elements in the array. Okay. So see here, example number 1. This is my nums array and this is a p value given to us. Okay, so what is the total sum of all the elements in my nums array? 3 plus 1 4, 4 plus 4 8, 8 plus 2 10. Okay, so 10, I will check if this sum 10 is completely divisible with this 6. Okay, let's see. 6, no, I am getting the remainder as 4. Okay, so what I did 10 modulo with 6 and I am getting 4. So no, it is not completely divisible by p, right? The sum of the elements in nums is 10, which is not divisible by 6. We can remove the sub-array 4 and the sum of the remaining elements is 6, which is divisible by 6. Okay, but here there are total 2 possibilities. I can remove this 4, okay, or I can also remove this 3 1, right? 3 1 is also one sub-array and it is continuous, right? So if I remove 3 1, okay, 3 and here it's 1 and here it's 2. Okay, so if I just remove 3 1, then the length of the remaining sub-array is 2, but this sub-array which I removed, its length is 2, right? And see, this is remaining part 4 2, right? 4 plus 2 is 6 and 6 is completely divisible by 6. Okay, I'm getting a remainder as 0. Okay, so here I'm getting length as 2, but this is not my output, right? My output is 1. Okay, so if I remove this just 4, okay, if I just remove this sub-array, this 4 only, then what is the total sum I'm getting? 3 plus 1 4, 4 plus 2 6, and 6 modulo 6 is 0 in that case, right? So this is also one possibility, and in this case the sub-array which I am removing is having length just 1. Okay, so this is what we need to do, right? We have to return the length of the smallest sub-array that you need to remove. Okay, that is why I'm simply removing 4, not 3 1. We can remove 3 1 as well, then also it will completely divisible by p, but we have to return the length of the smallest sub-array that we need to remove, right? So that's why we are seeing the output as 1. Okay, so I hope that you guys are clear with the statement, okay, with this statement and this example, right? So now let's see how we are going to solve this problem. Okay, so here this is my nums array, right? 3 1 4 2. Okay, so here one thing is that we can just simply calculate the sum of all the elements and just modulo that with the p value. Okay, so in this case p value is 6, right? So this is nothing but p. Okay, so if it is completely divisible by p, then we don't need to remove any sub array, right? But if it is not completely divisible by 6, okay, this p value, and there is some remainder, then we need to remove that particular remainder from this nums array, right? So this is what we need to do. Okay, but here let's suppose these numbers are very weak, then again we are going to do the summation, right? This number will be very large. In that case we will get some issues, okay, with our code. Okay, if the numbers are very large. So here if you see this problem statement, nums of I, so large number, right? 10 raised to the power 9. So what I'm going to do, instead of directly first summing all the values and then do the modulo with p, what I will do, I will just do the modulo side by side, okay, for a particular number. Okay, so first let's say I am at this number. Okay, so here I'm getting 3, total sum as 3 right now here, and modulo of 3 with 6, what is the value that I'm going to get? I will get 3, right? So 3 modulo I'm doing with 6, 600 here, remainder is 3. Okay, 3 I'm getting. Okay, this is the remainder that I'm getting here, 3. Okay, now I'm saying next time, so this is nothing but this is my total sum right now. Okay, and remainder and total sum as of now. Initially my total sum was 0. Okay, so now in this total sum 3, I am going to add 1. Okay, this is my next number, right? So in this total sum 3, I am adding 1, 3 plus 1, and again I am doing the modulo with 6. So what is the output I'm getting? 4 modulo 6. I will get my output as 4. Okay, so here I'm getting 4. So this is my current total sum. Okay, 4 at this point. Okay, then in this 4, just add this 4. Okay, this is what I'm doing. My next time I'm at this number. So here 4 plus 4 modulo with 6. So what is the output rate you are going to get? 8 modulo 6, 8 modulo 6. Okay, so 8 modulo 6 simply means 2, right? 6 1 just 6, and here remainder is 2. Okay, so here this is the total sum that I have right now. Okay, 2. Okay, at this position. Okay, then after that in this 2, add this 2 now. So 2 plus 2 modulo with the 6. This is what I need to do. 4 modulo 6. So I will get here remainder as 4, right? 4. So here I am writing 4, and this is correct na. In the end I was getting 4 here, and if I was directly doing the summation of this whole array, 3 plus 1 4, 4 plus 4 8, 8 plus 2 10, 10 modulo 6 is also 4. Okay, so in this way also I am getting the 4 output, and if I do the complete summation and then do the modulo with p, then also I am getting the same output. But this is much beneficial because if numbers are very large, okay, then it will be difficult, okay, to do all this stuff. So okay, so I hope that you guys are clear. So we need to do this. So in the end you see the total sum here, it is 4. Okay, that I'm getting. And okay, so if my total sum is not equal to 0, then we need to do further steps. But if the total sum is already divisible by p, okay, if the total sum that I'm going to get here is 0, then we have to simply return. Okay, we have to simply return 0 in that case. So here, okay, so I hope that this is clear. Okay, so here 3, I am getting 3. 3 plus 1 4, 4 modulo 6, I am getting 4. Okay, so this is also you can check right like this only. So 4 plus 3 plus 1 8, 8 modulo 6 2, you are getting right. Okay, so I hope that you guys are clear with this step. Okay, how I'm doing this. So now my remainder is 4. Okay, extra total sum that I'm getting in the end. Okay, this is the part now. So now 3 1 4 2. Okay, this is my nums array. So from this nums array, if I just remove this extra sum that I'm getting here in the end, okay, then definitely my remaining this nums array will be completely divisible by p, which is nothing but 6 right now, right? So here two possibilities. I can remove this 3 1, and or I can simply remove this 4. Okay, I can remove this part, or I can simply remove this one. Okay, but in this, if I remove this, the length is 2, and if I just remove this, the length is 1. So I have to return the minimum length. Okay, so now let's see how I'm going to achieve this. Okay, so I'm going to create one hash map. Okay, and in the hash map I'm going to store the my current sum, okay, as key. This is nothing but current sum as key, and I'm going to store the index as my value. Okay, so where I have seen this current sum, I will just store that particular index. Okay, so this is my nums array. Okay, let me write it again here. 3 1 4 and 2. Okay, so here this is nothing but 0 index, 1 index, and this is nothing but 2 index, and this is nothing but 3 index, right? Okay, so now here initially I am at this position. Okay, let's say my I is at this position. Okay, so now my initially my current sum is 0. Okay, so in the current sum, if I add this value, so what is the result that I'm going to get? Okay, so in my current sum I am using this formula. Current sum is equal to, initially current sum is 0. Okay, in this current sum I am adding the current number. Okay, nums of I can say, and after that I am just doing the modulo. Okay, I will just check the remainder, whatever the remainder that I'm going to get. here initially current sum is 0 and at nums of I I'm initially at this position. Okay, I. So here nums of I is 3 modulo, here it should be 6 na, p value. Okay, 6. Okay, so here I will get 3 modulo 6 is nothing but 3. I'm getting 3 here. Okay, but initially let's store one thing here. So at index -1, okay, my current sum is 0, let's say. Okay, my array starting from here 0 index, but at somewhere at here, this position, okay, at -1 index, let's say my total current sum is 0. Okay, so I have just stored this value initially. Okay, so this is useful right now as we are going to use the prefix sum calculation, right? So now once this is done, so here this is the current sum that I am getting here. Okay, then now let's calculate the target prefix sum we need. Okay, so how I'm going to calculate the target prefix sum? So target prefix sum is equal to current sum I have, and I'm going to subtract remainder. Okay, the total extra remainder, extra total sum that I was getting here. So 4. Okay, so current sum. Okay, this is my current sum minus remainder, extra remainder. Okay, extra total sum 3 minus 4. And after that there may be some negative values, right? Here if I just do the modulus, okay, if I just do the modulus of this one, I will get some negative value. So what I'm going to do in this, I'm just going to add 6 to make the remainder as positive. Okay, 6, or you can say p value. Okay, whatever the p value. So p value is 6 here. So and then do the modulus with 6. Okay, so I have explained, I think, this thing yesterday, why I'm adding this plus 6 here plus p and then do the modulus with p. Okay, to make the remainder from negative to positive. Okay, if it required. So here I was getting -1 modulo 6, so I will get some negative value. I don't need that. Okay, so here see now 3 minus 4 minus 1 plus 6, 5 modulo 6 is 5. So this is the target I'm getting. Okay, this is the target that I'm going to get here, 5. All right. Okay, so now I'm just going to check in this, if in my map this target is there. So in my map this target is not there. Okay, this 5 is not there. So what I'm going to do now, so I'm just going to store the current prefix sum in the map. Okay, current prefix sum is 3. I'm going to store this in the map. Okay, so I'm getting this current sum as 3. At which index? At index 0. Okay, this is done. So I have stored this. Okay, now after that my I is going to move to the next position. Okay, my I reaches at this position. Okay, so now what is going to be my current sum? So in last time my current sum was 3. Okay, so here let me just remove it. Okay, so last time my current sum was 3, so here I'm writing 3 plus nums of I this time is 1. 3 plus 1 modulo 6, I am getting 4 modulo 6, which is nothing but 2. Oh sorry, it is nothing but 4, right? 4 modulo 6 is nothing but 4. Okay, this is what I'm going to get. This is done, and then after that I reach here to calculate my target. Okay, so now see carefully. So here my current sum is 4 now. Okay, so let's use that 4, and my remainder is 4 only. 4 minus 4 plus 6, the model of 6, I will get 0. Okay, I will get 0 here. All right, so now see, now my target is 0 at this case, at this point. Okay, so now see here, my target becomes 0. So definitely see here, this is what I was using, and here my target becomes 0. So simply means that I can remove this part, right? So what I'm going to check, so target is 0, so I'm going to check if my prefix map, okay, this map contains this particular target which is 0. Yes, it contains this target, right? This 0 is there already stored. So now what I'm going to do, I'm going to calculate the minimum length. Okay, so how I'm going to calculate the min length? So my min length, okay, let's say ml, min length. Okay, this is nothing but math dot min of my min length, and here I minus from my map, just get that particular index. Okay, so from my map dot get, okay, this is nothing but my prefix map. Let's say from this just get that particular target value. Okay, so here minimum length initially I will assign the total array value. So total array size is 4. Okay, so for I, right now my I is at this particular index, which is nothing but 1. Okay, 1 minus where this value is present, 0 is present at -1 index. Okay, so here I'm going to write -1. All right, so now out of these two, what is minimum? 4, and here I will get 2. So out of these two, which is minimum? 2. Okay, so this is my current minimum length, right? And this is accurate, right? So I can simply remove this 3 one part. Okay, and then I will just get the remaining summation of my array elements is 6, which is modulo with 6 will give me 0. Okay, complete divisible by p. Okay, so this is true, this holds true right now. Okay, so minimum length right now is 2. So here let me write the minimum length that I have right now. Okay, 2. Okay, now after that what will happen? After that, let's say my I is moving to this position. Okay, and here this is already there now, uh, 0. Okay, so right, this was the current sum last time I read got. Okay, so I have to just update this current sum as well. I was getting current sum 4, and at which index I was getting that? 4. I was getting this at this 1 index last time. Okay, from last time I have stored this. Okay, 4 I was getting at 1. Okay, 3 plus 1 is 4, and 4 was I was getting at 1. Okay, this is done. Now after that my I is at this particular position. Okay, now my current sum is going to be, last time current sum was 4. Okay, so here let me just remove it. Last time, just remember this, last time my current sum was 4. Okay, so I'm removing it now. So here I'm writing 4 plus, now what is the number? 4. I'm getting 4. 4 plus 4 modulo with 6, I will get 8 modulo 6, which is nothing but 2. Okay, this is what I'm going to get, 2. Alright, now after that just calculate the target. Okay, so current sum is 2 this time. So here I'm just going to change it to 2 minus remainder 4 plus 6 modulus with 6. 2 minus 4 is minus 2. Minus 2 plus 6, 4. 4 modulo 6 is nothing but 4. So target I'm getting is 4. Okay, now this time my target is 4. Okay, so now what I need to do? Okay, so again I will check if my map contains this key 4. Okay, target key. So yes, my map contains this key 4, right? So what I'm going to do, I'm calculating the minimum length. Okay, in that case, so minimum length previously, now previously it was changed to 2 now, so let me just change it to 2. And now my I is at this index, this 2 index, so here I'm just going to change it to 2. Okay, and here minus pm dot get target. Okay, so for 4 value is 1, so here I'm just going to write 1. Okay, this is 1. So 2, and here 2 minus 1, which is nothing but 1 here. Okay, out of 2, 1, which is minimum? 1 is minimum. Okay, so I'm going to update my minimum length to 1 now, and this holds true now. This holds true. I can simply remove this element, and then again 3 plus 1 plus 2 is going to give me 6, which is completely divisible by 6, right? So this holds true. Okay, so this is done. Then after that, in my prefix map, I'm just going to put this. So 2 was the sum I was getting, and at which index I was getting this? I was getting this at this 2 index. Okay, so here I'm going to store this 2. Okay, now this is done. Then after that, my I is going to move to this position, right? And now again current sum, from last time it was 2, so here I'm just going to use 2 plus nums of I. This time it is nothing but 2. 2 plus 2 is 4. 4 modulus with 6 is 4. I'm getting my current sum as 4 now. Okay, getting my current sum as 4. Alright, okay, right. So now target. Okay, so here current sum is 4, so here let me just remove it. So let me just update it directly. 4 minus 4 plus 6 modulus with 6, I am getting target is 0. So this is already there, I think, right? This 0 is already there. Yes, at minus 1. Okay, so let's calculate the minimum length now. 1 minus 1, here I have operated 1 minimum length from last time, and this time my I is at this index 3, right? 3 minus, and here 0 I'm getting. So here I will write -1 now. So 1 comma 3 plus 1 4, minimum is 1 only. So this is done. In the end 1, and here current sum was 4, okay, which I was getting here. And okay, so we have to just store the current prefix sum in the map. Okay, so I was getting this 4 again at which position, at index number 3. Okay, here I can just update it. So once this is done, so now we have covered all the elements, right? So in the end I am just going to check if my mean length is equal to this total length. Okay, if it is equal to this total length, then in that case simply done -1. But if I get some mean length value, then I have to simply done it. So in the end I'm just going to simply done this one, right? So now let's write the code. Okay, I'm just going to write the same story that I've explained here. Okay, so here inside this, first take my total sum as 0. Okay, int total sum is equal to 0, and then let's iterate over all the elements in my nums array. Int num over nums, and now after that just update the total sum is equal to total sum plus num. Okay, total sum plus num, and then do the modulo with p. Okay, so we are only caring about the mod p, right? So this is done. Then after that, in my next step, I'm just going to check if my total sum is equal to 0. Then we have to simply return 0, right? If the total sum is already divisible by p, return 0. So that's what we need to do here. If total sum is equal to p 0, then just simply return 0. Okay, that's it. Now after that, let's create one variable int remainder, and in this remainder I'm just assigning this value total sum. Okay, so here this is the remainder we need to remove, right? This is the what we need to remove. Then let's create one hash map. Okay, and in my hash map I'm just going to store integer values, right, as key and values. Okay, and let's name it as prefix map. For simplicity, prefix map is equal to new hash map. Alright, and then after that, in my prefix map, just add the initial values, right? Prefix map dot put 0 and -1 we need to put, right? 1 second. 0 and -1 we need to put. Alright, so here this is to handle sub arrays starting from the beginning. Okay, that's the purpose of this one. And then after that, take current sum as 0. Okay, and min length, initially let's give the size as full. Min length is equal to my array name nums dot length. Okay, then after that our step number 3 is going to be traverse through the array. Okay, so for int I is equal to 0, I is less than my nums dot length. Okay, nums dot length, and here I plus plus. Okay, inside this I will just check my current sum. Current sum is equal to current sum plus my current element nums of I, and I'm just doing the modulus, right? Modulus with p. Okay, this is done. Then we have to calculate the target prefix sum we need. Okay, so int target prefix sum that we need, so it is going to be int target is equal to my current sum, and in this current sum I have to subtract the remainder. Okay, and then to make sure that we are getting positive values, I am just going to add p and then do the modulo with p. Okay, this is done. Then after that I am just going to check if my prefix map dot contains this particular target. So I have explained all these things. Okay, I give the dry run on one example, right? So I'm writing the same thing. So here, if this is the case, then I have to update the mean length, right? Mean length is equal to math dot mean of mean length, and here I have to write I minus prefix map dot get target. Okay, and after that we have to just store the current prefix sum in the map. Okay, this is what we need to do every time. Prefix map dot put current sum. Okay, this is what I am going to update in my prefix map, and I'm just going to store the index. Alright, this is done. That's it. Okay, now here just one more step is pending, that is if no valid subarray was found, then return -1. So I told you now, just check the length of this mean length. Okay, if this mean length is equal to my nums dot length, okay, that simply means there is no update in my mean length. Okay, so in that case, if this is true, return -1. If it's not true, then return the mean length that I have obtained. That's it. Now let's run it and see if there are any code issues. Then we will try to fix that. Prefix map dot contains key is missing now. I need to add the key as well here. 1 second. Prefix map dot contains here right key now. I was checking for key KEY. Okay, now let's run it. So all the test cases has been accepted. Now let's submit it. And the time complexity for this problem is going to be of n only. So here we are just iterating over all the numbers one by one. Right, so our solution is accepted, right? And also here we are creating one hash map, and again here we are iterating over all the elements in my nums array one by one. Okay, so you can see the time complexity from here. It is nothing but of n, right? So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.